This is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. Today I am going to explain about Euler's and modified Euler methods. So the main objective of these methods are to solve first order initial value problems numerically. So in the last class we have discussed Taylor series method. Now we are going to discuss about Euler's and modified Euler's method, how this method will help to solve first order differential equations. Euler's method is a single step method. So single step means the point it is the slope of the point at regular point only to solve ordinary differential equations, and starting point of the solution curve and slope of the curve at a starting point are given. So starting point of the solution curve is, so y of x naught is equal to y naught. So for example, y of 1 is equal to 2. So here x naught value is 1 and y naught is 2. And the slope of the curve starting point. So slope of the curve is dy by dx is equal to f of x comma y. So the derivative of y with respect to x is the f of x comma y, and this is the slope of the curve. And both the starting point as well as the slope of the curve are given. So this method can extract the solution curve using a specified step size. So with the specified step size, we can extract the solution of the given curve. So now consider the first order differential equation, that is dy by dx is equal to f of x comma y with the initial condition y of x naught is equal to y naught. So using this initial condition, so we can find the initial slope f of x naught comma y naught. Now consider this equation dy by dx is equal to f of x comma y. Now integrate this, we get the solution of Euler's method. So I am integrating between the limits y naught to y, dy is equal to integration of x naught to x f of x comma y into dx. So this y dy with respect to derivative integration of y, so this is under the limits y naught to y, so we get y naught minus y is equal to, this is f of integral x naught to x f of x comma y dx. So this y naught is equal to y plus integral x naught to x f of x comma y dx. Right, so integral y naught to y dy is equal to integral x naught to x f of x comma y dx. So that is y minus y naught is equal to integral x naught to x f of x comma y dx. So y is equal to y naught plus integral x naught to x f of x comma y dx. So we take the interval x naught to x1 and x1 to x2 and so on. So now consider the interval, let f of x comma y is equal to f of x naught comma y naught in the range x naught and x1. So thus we can write the above equation as y1 is equal to y naught plus integral x naught to x f of x naught comma y naught into dx. So similarly, if we take in the next interval x1 and x2, so we can write y2 is equal to y1 plus integral x naught to x1, this is x1 to x2, previous interval is x naught to x1 and this is x1 to x2 f of x1 comma y1 into dx. So similarly, we can write nth order yn plus 1 is equal to yn plus h into f of xn comma yn, or we can represent this yi plus 1 is equal to yi plus h into f of xi comma yi. So this is called Euler's method formula. This is called Euler's method formula. So using this formula, we can calculate the value of y corresponding to x. Now we can see the example. Using Euler's method, find the value of y.01 with step size is given, that is h is equal to 0.025 for the given differential equation dy by dx is equal to y minus x by y plus x with initial condition also given y of 0 is equal to 1. Now using this we can find the value of y of 0.1 with the given differential equation dy by dx is equal to y minus x by y plus x. So here f of x comma y is equal to, we can write y minus x by y plus x, and initial condition x naught is equal to 0, y naught is equal to 1, and also given the interval difference h is equal to 0.025. So I will tell the simple way to solve this problem. So we are taking this table, and this is the x value or xi given, and this is the yi and f of x comma y, and this is the new value of y is equal to y plus h into f of x comma y. So here we are taking the initial value as 0 because x naught is 0, and initial value of y is, that is 1. So x value is 0 and y value is 1. Now we are taking a functional value of f of x comma y. So 0 and 1. So what is the function here? F of x comma y is equal to y minus x by y plus x. So that is 1 minus 0 by 1 plus 0. So we'll get 1. So here the function value is 1. Now you substitute this value in new y, that is y plus h into, so y means this is 1 plus h is the difference of the step size, so that is 0.025 into the function of f of x comma y is 1. So this value becomes 1.0250. So similar way, so we can take the value, this is the next step size, this is the next step size of x. So xi we can find xi plus 1 is equal to xi plus h. So we are increasing the step size. So xi plus 1 is equal to xi, that is previous value of x, that is 0, plus h is the interval difference 0.025. So 0 plus 0.25. So it becomes 0.025. Now this is the value which is we are replacing this value here, y value, and now we are finding f of x comma y. So that is y minus x by y plus x. We will get this 0.9524, and substituting this f of x comma y and y plus h, so we will get this value. So again we are increasing the step size 0.025 plus the previous value is 0.025. So it becomes 0.050. Now we are replacing this y value here 1.0488. Now this is the functional value. So we can substitute this x and y value in the function, given function. So we get 0.9090. So this is the new y value. Now again we are increasing the step size to 0.025. So it becomes 0.075. Now we are replacing this value here. So now the functional value of this f of x comma y is 0.8692. So this is the new value of y. So we get this one. Now again we are increasing to our target, that is 0.1. So now this value is writing here. So this is the required value. So the required solution is y of 0.1 is equal to 1.0933. So this is our x1 value and this is the y1 value. So this is our required solution. Now we can see the modified Euler's method. And what is the difference between Euler's and modified Euler's method? Now we'll see the modified Euler's method is a multi-step method, whereas Euler's method is single step method. So single step method means the slope only at the regular point. So here multi-step methods. So we can find slope at multi-point. So the predictor corrector method is also known as modified Euler's method. So in this Euler's method, the tangent is drawn at a point. The tangent is drawn at a point and slope is calculated in the given step size. Tangent is drawn at a given point and the slope is calculated at a given step size. So this method works only in linear functions, but whereas in other cases, so there remains a truncation error. So to avoid this problem, so we can go with modified Euler's method. So the modified Euler's method can be introduced here. So in this method, so instead of taking the slope point, so we will take, so in Euler's method we will take a slope point xi, but here arithmetic average of the slopes are given in the interval xi comma xi plus 1. So in the Euler's method we take the slope at one point, that is xi, but in modified Euler's method, so we are taking the arithmetic averages of the slopes, that is xi comma xi plus 1 average in the interval. So it can be used. Now there are three steps to compute the using modified Euler's method here. So this Euler's method, so first one is, the step one is we have to compute the value of yi plus 1. So using Euler's method, it is also named as predicted value. So this yi plus 1 of p predicted value is equal to yi plus h into f of xi comma yi. So this is, we have already seen just now, this formula of Euler's method. So yi plus 1 is equal to yi plus h into f of xi comma yi. So here we are taking the predicted value, so we are writing p. So yi plus 1p is equal to yi plus h into f of xi comma yi. So here h is the step size of equal length. So now the step 2 is we have to compute the slopes. We have to compute the slopes at given points xi comma yi and xi plus 1 comma yi plus 1 p. So here the predicted previous value we are substituting here. So we are taking the average of the slopes xi comma yi and xi plus 1 comma yi plus 1 of p. So now we are pointing the slope at a functional point f of xi comma at this point xi comma yi. So that is f of xi comma yi, and the slope of this point is f of xi plus 1 comma yi plus 1 of p. Now that is the given function dy by dx is equal to f of x comma y. So with this function we are substituting this slope of points here. So we are getting the slope points f of xi comma yi and f of xi plus 1 comma yi plus 1 of p. So now take average of these slopes. Taking average of these slopes and adding to the value of y, now we can calculate the yi plus 1 of c. So that is yi plus 1 of c is equal to yi plus h by 2. We are taking the average of these two, xi comma f of xi comma yi and f of xi plus 1 comma yi plus 1 p of p h by 2, plus we are adding to this yi. So we will get the corrected value of yi plus 1 of c. So that is yi plus 1 of c is equal to yi plus h by 2 into f of xi comma yi plus f of xi plus 1 comma yi plus 1 of p. So using these predicted value and corrected value, so we can calculate the value of y in the given interval. Now we can see the example. So using modified Euler's method, we can obtain the solution of given differential equation, that is dy by dx is equal to xy. So with the initial condition y of 1 is equal to 5 and in the range 1 is less than or equal to x less than or equal to 1.4 with in the step size is 0.1. Now the given data, so this is dy by dx is nothing but f of x comma y is equal to xy and h is equal to 0.1, the interval difference or step size, and the initial condition is given x naught is equal to 1 and y naught is equal to 5. Alright, now using these data, so we are simply calculating given differential equation at the point 1 to 1.4, in the interval 1 to 1.4. So we can use this predicted and corrected values, so that we can easily get the data. So using predicted and corrected values, we get the data like this. So this is the given xi values and yi, and we are finding the function of f of xi and yi, and this is yi plus 1 of p. So we already know that yi plus 1 of p. So using Euler's method, so we can write this formula as yi plus 1 of p is equal to yi plus h into f of xi comma yi. So this is the predicted value of Euler's method, predicted values or Euler's method. And now we can write this yi plus 1. So we are increasing the step size so that we can get xi plus 1. So what is xi plus 1 is equal to xi plus h. So we are increasing the step size. So it becomes 1.1. So now initially the x0 value, xi value is what? 1. And we are incrementing the step size so that it becomes 1 plus 0.1. So 1 plus 0.1. So 1.1. And again we are increasing the step size. We are improving the step size. So we'll get 1.2. So 1.1 plus 0.1. So it becomes 1.2. Again improving the step size. So we'll get 1.3 and 1.4. So the required interval is 1 up to 1.4. Now yi plus 1 of c. So that is we'll get this corrected value from this formula. Yi plus 1 of c is equal to yi plus h by 2 into f of h. Right here. So yi plus 1 is equal to yi plus 1 c is equal to yi plus h by 2 into f of xi comma yi plus f of xi plus 1 comma yi plus 1 p over p of p, predicted value. Okay, right. Now so we can improving the values of x, so we will get up to 1.4. Now corresponding y values, so y0 is, so the initial value is 5, y0 is 5 here. So we are taking 5, the y0 value is 5 and x0 value is 1. Now we are this the functional value of f of xi comma yi. So what is the functional value of f of xi comma y? So this is xi, xy. So substitute these values in x into y. So that is 1 into 5 is equal to 5. Now take the formula of yi plus 1 of p is equal to yi plus h into. So what is yi? 5 plus we can write 5 plus and h, interval difference is 0.1. 0.1 into the functional value of f of xi comma yi is 5. So 5 plus 0.5, so it becomes 5.5. Now this is the value of incremented value of 1.1. So using xi plus 1 is equal to xi plus h. So that is 1 plus the previous value is that 0.1 h value. So xi value is 1 and this h value is 0.1. So 1 plus 0.1 is 1.1. Now we can improve this value in 1.2 and next improvement 1.3 and 1.4. So now we can substitute here f of xi plus 1 comma yi plus 1 of p. So what is xi plus 1? So xi plus 1 is 1.1. Substitute in the given function, and yi plus 1 is 5.5. So multiply these two values, will get 6.05. And yi plus 1. So in this formula, substitute in this formula, yi plus 1 of c is equal to yi plus 5 plus h is 0.1 by 2. And the functional value of this is 5 plus f of xi plus 1 is 1.1 and yi plus 1 is 5.552 So multiplying these and take the average of these, so we'll get 5.5525. So in this way we can, so the next improvement value is 1.1 and again its 5 value is, we are replacing this value with here. So we'll take the f of functional value of f of xi into yi. So we'll get this and we will continue this. So again replacing, we are improving this x value and replacing this with here, and we are finding these values. Next it is improving it 1.3 and this is the y value, corresponding y value, and again we are calculating these values. Now finally we get, so x is improving up to 1.4. So the required value is 1.4. So we are finding 1.4 and we are finding this value here. So this value here. So this is the required solution of y of 1.4. So our target is to find y of 1.4 is equal to 8.0713. So this is the required solution. So this we can find by using Euler's method. So the difference between modified Euler's and Euler's method is only the difference is, so there we are finding the slope at one point, and here we are taking the average of the slopes. And in some cases, so we cannot find we will get if the Euler's method can be applied only for linear functions. So in this case, in that case we'll get a truncation error. So to avoid that, we can use the modified Euler's method. So in the today's session, so we have discussed the Euler's and modified Euler's method. Euler's method and modified Euler's methods and their differences, and how to find using how to solve the using ordinary differential equations using Euler's and modified Euler's methods. In the next session, we will discuss Range-Kutta method, RK method, we simply call as RK method of fourth order. Thank you.